Hello, my name is Reed Abbott. I'm the agronomist for the Southeast region of the United States for Agro-Culture Liquid Fertilizers. And today, the topic that I'm going to discuss is sulfur, sulfate, so what? This is going to be an exploration into the importance and the role of sulfur in our soil and our cropping systems. Today, we're going to cover sources of sulfur, the sulfur cycle, sulfate in crop production, and then sulfur's role in the soil. Here's a list of sources of sulfur in the soil. First, we have organic matter. For every 1% organic matter, we're going to look to have that supply about 2 to 3 pounds of sulfur per year. Also, we have soil minerals, which makes up your parent material of your soil. Those provide inorganic sources of sulfur that later oxidize into sulfates and plant available forms. Then we also have atmospheric deposition, which is your acid rains and things like that. A lot of that sulfur is put into the atmosphere through our burning coal and through burning diesel and those types of fossil fuels. Here recently, due to the Clean Air Act and different things like that, those levels have dramatically been reduced in the atmosphere, so we don't get quite as much atmospheric deposition as we used to. But there still is a significant amount that's deposited across many of the acres that we farm here in the United States. We also get several pounds of sulfur in manure, irrigation water, and then of course your fertilizers and soil amendments. This illustration here is of the sulfur cycle, your natural components of sulfur, as you can see here, are illustrated in the green circles, and then inputs to soil are represented by the blue squares, and then loss avenues are represented by the red boxes. As you can see here, it's a fairly complex cycle with a lot of your losses coming through crop harvest, volatilization, and leaching, much like nitrogen. That atmospheric sulfur is deposited, as I was saying in the previous slide. We get a lot of that through burning of coal and a lot of our fossil fuels. So even though we've done a lot better job of scrubbing a lot of that sulfur out of our coal plants and out of our diesel trucks, we still do see quite a bit of sulfur coming in through acid rain events and those types of things. So to just hit on a few more points of the sulfur cycle, plants use that sulfate form or the SO4 form of sulfur. That's the form that they take in and utilize. Most sulfur in the soil is unavailable to plants as part of that soil organic matter complex, and that is slowly released to the plant available form through the weathering and decomposition of that organic matter. Sulfate sulfur is formed also through the bacterial oxidation of organic sulfur. So we actually rely on bacteria to take that inorganic sulfur and oxidize it to make that sulfate form of sulfur, SO4. So just to take this back to the illustration, you have that sulfate sulfur down there in the bottom center of this illustration. As you can see, due to bacteria, either assimilation or oxidation, you can have that go back and forth between organic sulfur or the sulfate form of sulfur. Also, bacteria can reduce that sulfate and give off hydrogen sulfide, which is then volatilized in the atmosphere. So that can be one of the loss pathways of sulfur in the soil. So, again, as you can see, these things can go back and forth, but really the only thing that we can control is the application of manures and mineral fertilizers as a source of sulfur in the soil. Loss pathways, as I was saying earlier, bacteria can utilize the sulfate for respiration, which in turn causes it to volatilize as hydrogen sulfide. Sulfate is not also held very tightly by the soil, much like nitrogen, so it can leach much in the same way as nitrogen. And then, of course, crops being harvested can remove sulfate from the soil as well. So I'm going to talk here a little bit about sulfate's role in crop production, specifically what it does within the plant to enable growth. Sulfur is used in the formation of amino acids and proteins. It's also necessary for your chlorophyll formation. So without this nutrient, we wouldn't have a whole lot of photosynthesis going on. It promotes nodulation in legumes, so it's going to help to uh, produce that nitrogen or help those rhizobiobacteria produce the nitrogen for your legume plants. And then also it develops and activates certain proteins and vitamins within the plant cells. So it's used as an activator or an enzyme or catalyst, so to speak, in a lot of your physiological processes within the plant. So as you can probably see from the previous slide, sulfur's role within the plant is very similar to nitrogen's role in the plant in that they are both responsible for protein synthesis and chlorophyll building and those types of physiological processes. So you can also deduce that sulfur's demand in the plant is closely associated with the crop's demand for nitrogen. This is due again to that protein and chlorophyll building as well as sulfur's role in converting nitrate into amino acids. However, sulfur is not used in quite the quantities that nitrate or nitrogen would be used in. So we typically use the ratios of about a 1 to 10 to 1 to 14 ratio of sulfur to nitrogen. So here I just wanted to point out some crops that show a very high sulfur response when that nutrient is applied and utilize a good deal of sulfur in their physiological processes. As you can see, many of these crops here are also high users of nitrogen. So even though they might be legumes or something like that, when you take into account their total nitrate usage across the season, most of them, due to that high nitrogen usage, are also big users of sulfur as well. Here I just wanted to illustrate a little bit of what sulfur deficiency looks like. Deficiency symptoms are much the same as nitrate, except sulfur is not mobile within the plant, so a lot of times you'll see that yellowing on the newer, younger leaves or higher up in the plant, versus nitrate, you'd see them lower in the plant or on the lower leaves because the plant can translocate that nitrogen up to the newer leaves. But yes, again, you're going to see that yellowing of the younger top growth, shorter plants in stature, reduced growth rate, reduced yield. Basically just a yellow, stunted looking plant where that yellowing is concentrated more to the upper leaves. So some of your more common fertilizer forms of sulfate include ammonium sulfate, ammonium thiosulfate, potassium sulfate, gypsum, Epsom salts, sulfamag, superphosphates, and then of course elemental sulfur. The sulfur also has a very important role in the soil. It's very effective at removing or leaching sodium and other cations that tend to be in excess in the soil. Calcium, magnesium, those types of bases or cation bases. When we apply sulfur to the soil, it has an acidifying effect by grabbing those bases and leaching them out of the soil. That lowering of the pH can help a crop out, especially if you're dealing with a high pH soil, by bringing that nutrient availability range back into the correct form. Most of our crops want that pH to be between 6 and 7 or 6.5 and 7. And by doing that, we can allow more nutrients to be available to that crop. So that's all I have for you today. If you're interested in learning more about sulfur and its role in the plant and in our cropping systems, feel free to visit these websites. Also, you can go to agroliquid.com and take a look at a lot of our research on sulfur and how we view it as an important nutrient in many of our cropping systems. Thanks.